Hi, my name is Aryan Jagannath, and this is my Physics 2212 Lab 2 report, Lab Lines of Charge. So, the purpose of this lab is to have a better approximation of the amount of charge on a piece of tape needed to make one tape float above the other. And we do this by treating each tape as a line of uniformly distributed charges. So the important physics principles here are E-field superposition, Newton's second law, F equals ma, and then also the electric force, which is given by this formula here for a rod or a line. So the models, these are the models that we've used here in this lab. Up here on the top right, you can see this is how we get one tape to float above the other one. And then here, this is a good approximation of what the charges look like. They're all across, like evenly distributed across the tape. And then I basically set the electric force equal to the gravitational force, since the net force is going to be equal to 0. Net force in the y direction is going to be equal to 0. And then you calculate the electric force using this formula here, where r is the separation distance between the two tapes, L is the length of the tape, Q is the charge of the tape. That's what we're trying to find using this formula here. And when I did this, the charge that I got was 1.04 times 10 to the negative 8 coulombs on one piece of tape. So here is the code that I had, and this is the output. So as you can see here, this code just calculates Q using the line charge model with the formula that I had shown in the last slide. And you compare the electric force to the gravitational force. As I said, you set those equal to one another, as you can see here. And then when you do that, you can see here the magnitude of the electric force and the gravitational force are basically the same, almost the same. And as you can also see here in this picture, the charge is distributed evenly across the tape, which is why you see all these green arrows here. And when calculating it using this model, we got Q equals to 1.04 times 10 to the negative 8 coulombs. The assumptions and the what ifs. The assumptions that we made were that charge is distributed evenly across the tape and that the air resistance can be ignored. We also said that the net force in the y direction on the tape is equal to 0, which is how we were able to set the gravitational force equal to the electric force. And then the questions here: what if you had modeled each of your tapes as a single point charge like in the first lab, and compare the estimated value of the charge you got? Well, in the first lab, when I did this with a single point charge, the approximation that I got was Q equals to 1.87 times 10 to the negative 9 coulombs, and that's about 18% smaller than the value I got with the line charge model in this lab, which was 1.04 times 10 to the negative 8 coulombs. And then why do these estimates differ? Which value is more likely to be closer to the real value? They differ because the line charge model is a different formula than the point charge formula. The point charge formula for the electric force is equal to K Q squared over R squared. And that only takes into account the separation distance between the tapes, because it treats it as one point charge. Whereas the line charge model takes into account the length of the tape, and basically the charge is distributed across the length of the tape. So because of this, the line charge model is more accurate. We use multiple point charges instead of just one to approximate the charge on a piece of tape, and so because of this, the approximation of the charge on a piece of tape using this line charge model is more accurate. And that's it. Thank you.